Hello and welcome to this afternoon session from VCAN. My name is Deborah Smith. I'm the Global Hygiene Specialist for VCAN, and we are a global producer of cleaning equipment for the food industry. Today, we'd like to share some of our experiences regarding the challenges and solutions associated with dry cleaning in the food industry. Before we start, there's a couple of housekeeping points I'd just like to run through with you. The webinar will be recorded and you will each be sent a copy of the recording after the webinar has finished. So don't worry if you have to leave the webinar at any point, you will be able to see the whole recording after the event. We will be asking you 4 poll questions throughout the webinar, which we'd really appreciate your answers to. They're very short questions and very short answers. We're just going to give you 30 seconds to respond, but they will help us to develop both our products and our webinars for the future. At the moment, you're all muted. If you'd like to ask a question or make a comment, please use the question section in the control panel on your screens to the, I think it's to the right of your screen. And then I will come back to the questions at the end of the session. Okay, so let's make a start. So we'll start by looking at the challenges associated with dry cleaning in the food industry. The first one is the cleaning with water is fun. I'm sure many of you will be able to associate with the picture on your screens at the moment. And that the inner child in you still enjoys messing about with water, whether that be in the garden or on the beach with your kids, or possibly at work while you're cleaning. And how many hygiene operatives in the dead of night during a cleaning session have felt or have imagined that the hose in their hand transforms them into a heroic firefighter. So psychologically, we have this association with water as being fun, and that can be a challenge when it comes to not using water as part of our cleaning. In addition, cleaning with water is much easier, much faster, and much more effective. So not only are we dealing with the psychological aspect of not using water, but the fact that actually it does the job very, very well. In contrast, cleaning without water is really hard. It means more manual effort, it's very tedious at times, and it can be awkward and boring. So again, psychologically, we're really up against the fact that not using water is something that we don't like to do. It also takes a lot longer, and that brings its own pressures in terms of loss of production time and time pressures on the hygiene team to get the cleaning done so that production can resume and so that the business can continue to manufacture and make money. So why should we dry clean? We've got all these reasons why we like to wet clean, but why should we not use water or try to minimize the use of water? Well, the first reason, and probably one of the primary reasons with regard to food safety in food production, is that water allows microorganisms to multiply. So we know that for microbes, and here I'm really focusing on bacteria, this is not relevant for viruses. For those of you that may have been dealing with virus issues over the last 9 months or so, really we're focusing very much on bacterial contamination within the food environment. But to multiply, bacteria will need food, they will need the right temperature, they will need the right respiratory gases, they will need the right time, and they will need water. Now, in a food environment, obviously we're going to have food. There's not an awful lot we can do to control the access of the bacteria to food because that is what we're producing. Also, the temperatures that we have to work at, because we have to employ people, are generally not lower than freezing and no greater than 40 degrees C. Normal working temperatures in food factories will range between 10 and maybe 20 degrees C. In chilled food factories, they will be closer to the lower end of that scale, and in ambient foods to the nearer the 20 degrees. But that means that the temperatures that we're working at are also very conducive to microbial growth. Some bacteria might be more adapted to the lower temperatures, for instance, Listeria at the chilled end, nearer to 10 degrees. But some of the more common ones that we associate with people, so E. coli, Salmonella, they're quite happy at growing at 20 degrees C. Then there's the atmosphere. Again, because we have people, we can't operate in an atmosphere that doesn't have oxygen in. And many of the food poisoning organisms that we're concerned with are quite happy working with oxygen as their respiratory gas. Some like lots of oxygen, some just like a little bit, but generally they're all happy to grow at that with that atmospheric gas. Then there's the time. We need time for the bacteria to grow, and we can limit the time we give them to grow by scheduling frequent cleaning. And the frequency that we determine our cleaning at will depend on many things, including the production environment, what we're producing, the temperature, the food, etc. But by limiting that time, we limit the microbial growth. And then there's the water. In some cases, we can't do an awful lot about limiting the water. The water comes in as part of the food product. We need water as part of the actual processing of the food product. We have people that come in and they breathe and they expel water as part of their respiration. So those are the things we can't really do much about. What we can do is try to limit the additional water that we bring in to the factory environment, particularly through cleaning. The second point we need to consider when we're thinking about water is that water spreads contamination. So it will allow the bacteria to grow, but it will also help them to spread throughout the factory. Now, there have been a number of studies that have looked at the spread of contamination by various routes that use water as a vector to transfer them. So I'm just going to take you through some of the research that has been done by Camden BRI, actually, both before I started with them and when I was working with them. So firstly, this is a picture of an ex-colleague of mine, Claire. She has been investigating the spread of contamination from footwear that have been made wet by walking through a piece of equipment which will hopefully be familiar to some of you, which is a boot washer. So that large piece of stainless steel equipment behind her is a boot washer, and in the bottom of that boot washer it's filled with a liquid, a water solution, which also contains a sanitizer. And the idea is that operatives walk through the boot washer before they enter production to clean and sanitize the boots before they walk into production. Obviously, as they do that, the boots become wet. So she's been looking at how far any contamination that might be in that boot washer solution or the brushes that clean those boots will then spread once she enters into production. What she's done is she's measured the distance that the red liquid within the boot washer has transferred onto a dry floor. And on a dry floor, she's been able to see that spread of contamination for a distance of about 24 meters. So wet boots on a dry floor, there's evidence that if there was any contamination in that boot washer, it could spread for a distance of 24 meters. Wet boots on a wet floor increase that spread of contamination. So the contamination can still be detected greater than 35 meters from the point where she's left the boot washer. Now, boot washers are fine as long as they're maintained in a fit state, that they're cleaned regularly, that the sanitizer solution is replaced on a frequent basis. But you can imagine that with the footfall that goes through them, there's soon a build-up of food, there'll be a build-up of bacteria within the food, within the brushes, and they could become a large source of contamination, which could then transfer to the boots, which could then transfer into the production area. And if that production area is wet, then that contamination travels a long way. You'll also notice that there's actually a leak on the washer, so you can see a big pool of red water to the side. That's not really what we're interested in. What we're interested in is this little area in front of the boot washer, where the action of the brushes while they've been cleaning the boots has also generated spray onto the floor at the exit of the boot washer. And again, if you have numerous people going through here, this area is going to become very wet, both from the feet that come through and from the spray. And again, that contamination can then spread into the production area. Continuing to look at the spread of contamination by footwear, if we take the boots and we inoculate them with a bacterial solution, and then we try to measure how much of that bacteria is transferred to the floor in the number of steps that takes place, we can see that the contamination spreads for 4 steps. So what we've done, we've taken what we call an agar contact plate, and we've touched this agar onto the floor where the feet have touched, and they will pick up any bacteria that have been transferred, and you can see how far the transfer occurs for. So you can see here there's been contamination that's been picked up by the agar plate after 1 step and after 4 steps, particularly on the heel of the boot. But after 4 steps and before 12 steps, then the contamination spread is very minimal. If you compare that spread of bacteria from the boot on a wet floor, we're now looking at greater than 15 steps. And when you look at the contact plate analysis of those steps, you can see that there's an awful lot more bacteria that are being transferred onto the floor and then being picked up by the contact plates, which indicates that the spread of contamination on that wet floor from the boot is much more significant. So in addition to looking at the transfer of contamination via water from boots, there were studies conducted to also look at the transfer of water, possibly contaminated water, onto the clothing as you go through the boot washer. So we also looked at the number of droplets that were deposited at the base of the protective clothing that you wear, the over coverings that you wear in the food production area. And what we were looking for was to find out whether those droplets were falling in an area that might then be in contact or close contact to food or food contact surfaces. So the lowest droplets were found at 7 centimetres, most of the droplets were found at 8 centimetres, and the highest droplet was at 21 centimetres. And actually that is an area fairly low down on the coat, so it's not likely that those areas are going to be in contact with food or food contact surfaces. We did the same thing with leggings or trousers, if you have protective trousers on, and here you can see that what we've done is we've wrapped Claire's legs in blue paper towel, and again any droplets that have been generated by the boot washer have then settled onto that blue paper legging, and we can identify them and see the number that are transferred. There's quite a few, but again we're talking about an area that's non-food contact critical. So feet, the bottoms of boots are probably critical for spreading into contaminant into the food production area, but the coat and the leggings, although contaminated, shouldn't really pose too much of a problem. So that was feet. Then we looked at hands, the spread of contamination via water when you're doing hand washing. And remember, these are all things that we're trying to do to minimise contamination spread into our food production area, but also to minimise water into our production area. So in this case, we set a sink up in an area of the labs, and we covered the floor in blue paper towel, divided into grids. And we got a number of people to go in and wash their hands, and then we recorded the droplets and splashes that were gathered on the floor, which you could see as they dropped onto the blue paper towel. You just drew around them with a different coloured marker pen, and in that way you get an idea of how many and how extensive the water transfer was from the sink to the floor. So not rocket science, but it is very effective at demonstrating the effect. We also then did the same thing where we laid agar plates around the sink. So each of the circles that you can see is an agar plate placed in the center of each of the grids. And the numbers that you can see in those circles are the number of bacterial colonies that developed after the plates were incubated. So you can see that around the sink, the number of bacteria that are released by the hand washing and fall to the floor in water droplets can actually give some fairly high levels of contamination on that floor. Again, that then can be picked up by feet or footwear and transferred into the food production area. In terms of the spread of contamination during hand washing to the protective clothing that we wear in production, again, we adopted this blue paper towel approach. So this is another ex-colleague, Karen, who's wearing this blue paper suit. She washed her hands on a number of occasions. And again, we looked at where the droplets fell on her blue paper suit. And you can see here that actually now the droplets that are transferred to the clothing when you're doing hand washing are quite significant in number, but also in an area that might be at a height which could possibly be in contact with food or food contact surfaces. So there's actually a significant impact of hand washing on the contamination of the protective clothing. And maybe it's that we wash our hands before we put on our clean protective clothing, and then maybe use a hand sanitizer just after we've entered production to prevent this happening. This is me some 18 years ago, I have to say, wearing a lab coat covered in agar plates. And the idea here was to do similar to what we did in the room with the sink, is to capture the droplets that are generated during hand washing and see if any bacteria are transferred along with the water. And again, here you can see the circles which represent the agar plates, and the numbers in the circles are the bacterial colonies that have developed after those plates have been incubated. So again, a significant transfer of not only water, but also bacteria to the protective clothing during hand washing. It's not only hand washing that's important when we're thinking about the spread of contamination. Hand drying is also very critical. So here we've looked at, we've got 5 people to wash their hands and then dry them for different periods of time, and then look at the transfer of the bacteria from their hands after 20 seconds of drying, which the hands are still quite moist, after 60 seconds of drying where they're actually quite dry, but then using 60 seconds of drying with an alcohol gel. The alcohol gel obviously also acts as an antimicrobial. And you'll see that obviously the number of bacteria that can be transferred when the hands are still damp is significantly greater than when they're dry. But the use of an alcohol sanitizer after drying decreases the bacteria availability for spread even further. Then let's think about cleaning activities. So we've cleaned the people, we've put them in protective clothing, and then obviously as part of the hygiene routines within the food factory, we need to do our daily or weekly, whatever it is, cleaning. All cleaning techniques, as I say, will spread contamination, but we can rank them in order of their impact, from the low-risk activities through to the high-risk ones. The low-risk ones, fortunately for dry cleaning, will involve things like vacuuming, wiping and scraping. We then move on to the more medium risk activities, which are things like scrubbing and sweeping, and then the high-risk activities of compressed air and hosing. Now, we're not using hosing, hopefully, in dry goods manufacture, in dry cleaning, but I'm going to show you the impact of a high-pressure hose on the spread of contamination, and we'll also cycle back round to the impact of compressed air. The trick with any of these is really to choose the right cleaning equipment and method to maximise the removal of the contamination but minimise its spread. So this is that example with high pressure hosing. And again, this is work done at Camden by a former colleague of mine, where she's using a high pressure jet of coloured liquid that she's squirting into a drain and then collecting the droplets that are generated on the strips of paper suspended on the boards in front of her. And by doing that on a number of occasions in a number of different ways, you can develop enough data to produce a model. And this is the model that was developed. So the blue arrow on the left is the point at which the high pressure hose impacts on the slot drain. And then in front of that, you can see the sheet, which represents the number and spread of the droplets that are generated. And you can see that those droplets spread for a distance of 7 meters forward and to a height of about 3.5 meters. And that means that you're actually potentially spreading any contamination that's in that drain over that area, both on the floors and possibly when those droplets settle onto open food or food product contact surfaces. So let's have a look at some of the dry cleaning solutions in terms of the equipment selection and use. Vacuuming we're going to start with. So vacuuming is quite commonly used in many dry goods manufacturers, and it has a lot of benefits. Firstly, it's very efficient at collecting the debris and then containing it so that it can then be safely disposed of. This is again some work we did at Camden. This was the work that I was involved in, where we were looking at how effective different dry cleaning techniques are at removing soil, dry soil from surfaces. So we've dusted this plate with flour and we've used a vacuum cleaner to remove it. And you can see that it's done a fairly good job with just one pass. It has pushed a little bit of the flour forward onto the black paper in the front, but if you pass the vacuum cleaner nozzle over that 2 or 3 times, it's going to very effectively remove that flour and contain it. However, there are a number of things you need to consider with vacuuming. The vacuum cleaners you need to use need to be ATEX certified. And that's because when you have a dry environment with possible dust clouds and you get an electrical spark, it can create an explosion. So the equipment needs to be certified against, oh gosh. Are you guys still with me? I think we just had a power cut at my end.
We can still see the PowerPoint. So
okay, I'll just work from the laptop. Sorry guys, I think I've had a power cut, which. So let me just continue where we were before. Let me just get back to here. Right. It's a great thing about this home technology. Yes, Maz.
Could you just move up your camera a bit so we can see your face?
Oh, are you seeing me on my oh gosh, yes. Hold on. Excellent. Not what we need. Let me just remove this one and this one.
There
right.
you go.
You'll have to tell me when you can see me, Matt, because I can't. Can you see me now?
Fine, thank you.
Thank you. Okay, reset. Sorry about that, guys. Technical difficulties with electrical power cuts at this end. Okay, so we're talking about ATEX certification and the fact that the equipment needs to be certified to ATEX ratings so that you don't risk those explosions in your dry atmospheres. The symbol that you need to be looking for on the equipment is the one that you can see here in the black box with the yellow hexagon and EX. The other thing that you need to do is ensure that the vacuum cleaners are fitted with appropriate bag and exhaust filters. Obviously, the vacuum cleaner is sucking in air and contamination. It also needs to expel air from the vacuum cleaner, and if you don't have appropriate bag or exhaust filters, then a lot of the contamination you suck in is likely to be blown back out again. So often people will fit these things with HEPA filters so that it's actually at a microbial level of control. Sorry guys, no, my mouse isn't working. So dink, 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 dink. Excellent. One of the other challenges that we've come across regarding vacuuming is that there are very few vacuum manufacturers that make vacuum nozzles that are colour coded. Now, we use colour coding in the food industry quite commonly to segregate between food contact and non-food contact equipment, for equipment used for specific allergens, and also maybe for specific tasks like glass cleaning, where we need to make sure that that hazard is completely segregated from anything to do with food. And because that doesn't exist so readily within the vacuuming tool range, people come up with their own solutions. So these are some examples of solutions that we've come across where people have used coloured insulating tape to colour code the vacuum nozzles for different uses. As you can see, after a while the tape becomes quite brittle and starts to flake off. It can also create a huge problem in terms of trapping contamination, both on it gets quite sticky after a while, or you get pockets within the tape where contamination can get trapped. So the use of coloured tape, not ideal with regard to foreign body risk or the trapping of contamination. And this is something we wanted to try to help with. So we actually developed these different coloured silicone bands that can be put onto vacuum attachments to try to give a secondary colour coding for segregation by use. And they are available in 2 different sizes, which so far we've found fit most of the vacuum attachments that the industry are using. So that brings us to our first poll question. And the question is, if VCAN were to produce coloured vacuum nozzles and brushes, would that be of interest to your business? And we've only given you a couple of responses, or 3 actually, I think here. So yes, please keep me informed. Maybe, please keep me informed. Or no, we're happy with our current situation. So if I could ask you to just spend a couple of seconds replying to those poll questions, it'd be very much appreciated. Thank you. I think Maz will close the poll when we're finished, which looks like he's just done that. So thank you very much. We'll move on. Okay, let's now look at wiping. So wiping is another low risk activity that we quite commonly do within actually all food production, but within dry food production, it's quite a common technique. And many of you will already be using disposable fabric or paper towels as part of your dry cleaning regime. They're very good, they're disposable, but because they're disposable, they're not particularly durable. And one of the biggest problems is the loss of fibres from things like paper and disposable fabric towels, which can in themselves cause an issue with food quality. The other thing that's available to you are microfiber cloths. The benefit of these is that they tend not to leave any fibres or linting. They're also now available in different colours and different types of textiles so that you can pick something that's more suitable for a particular type of cleaning. We've seen the use of cloths in the food industry quite commonly. We've obviously seen them more recently used now in food service and food retail, particularly for cleaning of the perspex screens that we've had to erect either between workers in a food factory or between customers and workers within food retail or food service. So having the availability of cloths that can be used for cleaning in food manufacturing or cleaning in food retail and food service is actually quite essential. One of the benefits of microfiber is that they are capable of cleaning without the use of chemicals and with the use of minimal water. If you want to disinfect a surface, that's a different story. Microfiber on its own will not disinfect. You would need to use a disinfectant chemical. But with regards to cleaning, they're actually highly effective at removing and retaining dirt and debris. And they can be used in a number of ways within the dry cleaning environment. So you can use them dry or you can use them damp. And when I mean damp, not wet. They literally are dosed with a very small portion of water, which helps, it actually improves their cleaning under those circumstances. So if they use dry, they're perfect for picking up dry dust and loose dirt. Not at a very heavy soiling level. They really need to be used after the bulk of the contamination has been removed. But then you can go over them with a dry microfiber cloth. Or if they're damp, they're really good at removing that stubborn, dried on dirt, including things like oil and grease. And this really surprised me, actually. We actually had a case study, which I'm going to show you here, which really left me quite gobsmacked. So this was a case study of this is wall cladding in a dry snacks factory, where they fry the dry snacks. And over a period of time, grease builds up on the wall cladding, which is the dark yellow that you can see at the top of the picture. And just using a microfiber mop and 80 mils of water, the factory were able to clean that cladding to remove the heavy grease deposits. And you can see the two stages of cleaning. So the first stage is the pale orange, where they've gone over the surface once with one cloth, one mop. And then the second, where it's fairly white again, is where they're cleaned with a second mop. So really incredibly effective with just using water, and that really did surprise me too. But so that's really all I wanted to share it with you. The surfaces will be left clean and relatively dry. They might be very damp, just slightly damp, but that will evaporate very quickly. But you're also not evaporating large volumes of water back into the environment, which could then condense and drip back down. There's also no need to bring large volumes of water into the production environment. You can prepare the cloths and mops in an area outside of production before they come in, which means you don't have to bring in those large volumes of water. And obviously overall, they will help you reduce the water you use, the amount of water you use, and the amount of chemicals. And in terms of sustainability, I know a lot of you will have of those as targets within your food production. You can also use microfiber to clean large vertical surfaces, and I'm sure many of you will have these large stainless steel surfaces within your food environment. They can be effectively cleaned using normal cloths, as shown here, but you get this smearing effect. Now, it's not an issue with regard to food safety, but it might be something that you want to eliminate so that things look bright and shiny, and microfiber will do that for you very nicely. And again, microfiber has been very regularly and commonly used within food retail and food service for cleaning larger surface areas. And again, we've seen an increase in this related to the control of COVID-19 over the last few months. One of our most popular products, I have to say, is this Easy Shine kit. I think because you can operate it without actually touching the mop, and the mop can be removed, ready to go into a washing machine with gloved hands. One of the things that I really desperately hate seeing when I go into any food factory, let alone a dry food factory, are these wet mop systems. So these mopping systems can not only be a great source of water and subsequently contamination, but can then spread that contamination all over. Even if the mop heads are changed every day, once you've made that mop head dirty, you're then putting it back into rinse water, possibly on numerous occasions, which means that you're then spreading the contamination that's in the mop water back onto the floor. So if we can do anything to avoid wet mopping, especially within a dry production environment, then we want to. It's quite difficult in food manufacturing where you've got heavy levels of soiling, but we'll come back to things like sweeping and the use of scrapers and squeegees for that. In food retail and in food service, where you haven't got the high levels of soiling that you get in a food factory, then again, microfiber used dry or damp is very effective at cleaning those floors. And you also eliminate the possibility of slip hazards with water being left on floors, so your customers are not at risk. Now, if there's also microfiber that's available for use in specialised area cleaning. So you can now get these microfiber mitts or gloves, which allow you to clean around things that are not particularly flat in geometry, or are maybe complicated where you need to get your hand inside for cleaning. Or there's equipment available that can get into narrow spaces, maybe behind rails or pipework, so that you can clean behind those. And there are kits that can be fitted to extension handles for high-level cleaning. Now let's have a look at scraping. So scraping is great for removing stubborn debris, and that's stuff that's been dried or baked on, or heavy deposits, maybe of grease or of confectionery. The type of scraper that you choose will very much depend on the surface you're cleaning. They come in a range of different styles and fabrics. So you can get metal bladed scrapers, you can get plastic bladed scrapers, you can get nylon bladed scrapers. If you're cleaning a metal surface, a metal scraper is probably not your best choice because you may cause damage to the metal surface. Equally, if you're cleaning a conveyor belt of soft material, a metal scraper might damage that too. So there you might want to go for a plastic scraper. If your surface is hot, then a nylon scraper could be good because the nylon is heat resistant, so it won't melt as you're trying to clean that surface. You'll then also want to choose different possibly blade shapes and sizes and thicknesses depending on what you're cleaning. If you're cleaning a floor and scraping material off there, the pressure that you apply to the blade means that the blade probably has to be thicker. You'll probably also want something that's bigger so that you can clean a larger surface area at a time. And then you might want scrapers that can be used to reach into either high level or deep inside machines. Most scrapers that have been available to date are the handheld ones. And you'll see off this next slide, what we identified was that sites were taking the handheld scrapers and making their own versions of extensions. So either by screwing or welding them onto an extension handle that they fabricated themselves, or just taping them onto existing handles. Now they're great because they solve the problem, but they really do introduce a number of problems with regard to foreign bodies, to hygienic design. They're very poorly hygienically designed. You can't clean them properly, and they're obviously not audit worthy, so could issue a non-compliance from an audit. So, but we actually love finding these kind of things because we take these ideas back to our fantastic R&D department, and we work with our designers to come up with solutions. They work closely with the sites where these issues have been identified, and ultimately we try to develop a solution that works for them. In this case, a scraper that can be fitted to any length handle depending on your need. Now let's look at scrubbing and sweeping. So these are primarily the ways in which you remove the gross debris from either the floor or the surface that you're producing on. And I don't think any of this is rocket science. If you're trying to remove loose dry powders, then you use a soft bristle brush. If you're using, if you need to remove dried on soils, then a stiff bristle brush can be used to give a bit more abrasion to remove that. But here's one that came up for us with feedback from some of our food industry partners, that maybe using a brush isn't always the best option. Maybe you could use a squeegee instead. They're actually incredibly effective at removing loose, dry debris from surfaces, and they don't clog like the bristles of a brush, and they're also much quicker and easier to clean afterwards. So if you've been having problems with clogging and cleaning of brushes, maybe think about trying a squeegee instead. Sometimes you're not going to be able to use a squeegee, and we have seen instances, particularly with brushes in confectionery and bakery, where they get clogged very quickly and are very difficult to clean. There are brushes available now that have been designed to clog less quickly and to be easier to clean, so it may be that you want to look into those options. Then we come to detail cleaning. Now, when you're cleaning with water, the water does a really great job of getting into those nooks and crannies, and if you're using it at any kind of pressure, it can actually help clean in those small spaces. When you've not got water to help you clean, it's really about having the right detail cleaning tool to get into the nook or cranny that you're trying to clean. And again, there are many different versions of detail cleaning equipment out there to help you get into those nooks and crannies. You'll recognise the brush that's just appeared from the previous slide. This was one that we identified in a bakery, and you can see the piece of equipment below with the area that this brush was being used to clean. It's a particularly narrow area, and obviously they were finding it difficult to clean. So again, we worked with them to replace this wooden shafted hand made brush with something that was a more professional solution, which was also capable of cleaning in other small gaps and spaces. Then we come to sweeping. So this is probably the most commonly used method in any food production environment for cleaning, but particularly in dry cleaning. What's important here is that you're moving the contamination from one place to another. And the way that you do that can actually create a spread of contamination. So here, again, study from Camden, we've put flour onto this stainless steel plate. We've used a broom to remove it from the plate and push it forward. But as we've done that, obviously it's spreading over a bigger area. Now, the more aggressive we are in our sweeping action, the more that contamination is going to spread. And then that makes it difficult for us to collect it together and remove it from where we need it to be. So we need to be training operatives on how to clean in a way that also minimises the spread of contamination by using controlled movements of brushes and brooms so that we don't spread it as much as we have here. We then also need to collect that contamination, and that could be using a vacuum cleaner or a dustpan and brush set, whether it's a long-handled or a traditional handheld set, or shovels if you're dealing with a large volume of dry material that you've gathered together in one space and then you need to remove. And then compressed air. I mentioned about compressed air being a high-risk cleaning activity. And as you can see from both this picture and the work, again, that we did at Camden, where you're using compressed air to remove dry powders, all you're really doing is spreading that contamination around. You're not actually removing it. You're just taking it from one area to the other, and you're losing control of where that contamination goes. To try and gather that contamination together again, even using a vacuum cleaner, might be incredibly difficult and time consuming, and particularly if it's an allergenic dry powder that you're trying to control. I work in more detail at Camden, where we looked at how long particles, dry particles that had been aerosolized using compressed air stayed in the air. So this is, we collected air samples using a particle counter, and in this graph you can see the different particles are depicted in the different colours, so the different particle sizes. And we're looking at the number of particles versus the time. The large particles fall out of the air within about 5 minutes, but the others remain in the air for 16 minutes. We actually stopped the experiment at 16 minutes because there didn't seem to be any significant change. And those particles can spread an awfully long way in 16 minutes and then settle back down onto food or to food contact surfaces. So that brings us to our second poll question. We've shared with you here today some of the challenges, some of the solutions, and some of the ideas that we've come across with within the food industry. And we'd like to ask you if there are any dry cleaning challenges, solutions, or ideas you'd like to share. And it's a simple yes or no answer. So yes, if you'd like to share some ideas, we will happily contact you. If no, and you've got it all under control, then great. So I think Maz will now launch that second poll. And again, we'd appreciate your response. We'll just give you 30 seconds to respond, and then we'll close that poll. Again, don't forget that if you have any questions, you can either wait till the end, or you can be submitting those questions to Maz as we go through the presentation. Great. Okay, so we'll move on now. After we've done the cleaning, we obviously need to clean the cleaning tools. And this is actually a legal requirement and is something that appears in at least 3 of the global food safety standards. So cleaning of the cleaning equipment is also critical. Now, this will often involve the use of water, and this is where the problem begins in dry food manufacturing. As soon as you introduce water into anything, you're going to have those problems with microbial growth and spread. So how do we get around this when we're looking at the cleaning of cleaning tools? The primary thing to do is really to inspect and clean and replace your equipment really frequently and regularly, because in that way you can avoid the gross buildup of debris within the equipment that will then take a lot of removing and a lot of time and effort if you're trying to do it with a dry process, or it will mean that you have to go to a wet cleaning process. So regular cleaning, inspection and replacement of the tools is the primary control. If you go to dry cleaning of the equipment, then you'll be looking at using another brush to brush down the equipment that's dirty. You can knock it gently to remove any debris that's in the brush or on the equipment, and you can shake it. In some food industries, we've actually found that they don't clean the brushes at all. In high-risk dry food production, like the infant formula production, they might only use a brush once and then throw it away. That's what they've deemed to do to ensure the safety of their consumers, which in this case is obviously infants. But obviously it's very wasteful for them, it's expensive for them, it's great for us, we sell more brushes, but it's not really the end point. From a sustainability point of view, from an environmental point of view, that's not what we want to be doing. So we need to be looking at effective dry cleaning measures for that equipment. Sometimes you won't be able to do dry cleaning, particularly in confectionery where you've got chocolate or sugar deposits on the equipment. You will have to go to wet cleaning. So let's have a look at that now. The most common method for wet cleaning is just to immerse the thing that you're trying to clean in warm water containing either a detergent or a sanitizer, and then to agitate it or scrub it with another piece of equipment, or just shaking it in the water. It should then be, if you're going to use it in dry cleaning, you should then rinse it thoroughly and then dry it thoroughly. And drying can be a challenge. If you've got access to a hot cupboard or an oven, then most of the equipment can be adequately dried in that hot cupboard, but you obviously have to give it time, in which case you might have to have a second set of equipment that you can use while the first set is drying. You can also use automated washing systems. So I've seen cleaning tools and equipment cleaned using tray washers or equipment washers, or even industrial washing machines. So you can load the equipment into these machines. To aid the drying of the equipment, we would recommend using a rinse aid, a hot water rinse at the end of the cycle, and then opening the equipment, the machine, at the end of the cycle to allow evaporation and more quicker drying of the equipment. do just have to point out that dishwashers, because of the water jets and the high pressures and temperatures that they operate at, you can get some deformation of soft bristle brushes. You can get them back into shape, but you have to put them back into water, so that's not really the point. What you can do is you can actually put them into washing machines. So in addition to washing microfiber products in a washing machine, you can also wash cleaning equipment in washing machines, and then you don't get the same issue with the deformation of bristles. And if you'd like to find out more about that, you can just use the link that I've shown at the bottom of this slide. And then obviously after you've cleaned everything, you want to be storing it properly. You don't want to be chucking it in a heap in the corner to get dirty again or damaged. You want to be storing them on shadow board, on equipment racks appropriate to your needs, or even onto shadow boards. So that brings us to our third poll question, and that is, when was the last time you had a complete review of the cleaning tools used on your site? We have a number of options here. The first is more than 24 months ago. The second, within the last 24 months. Then within the last 12 months. And then within the last 6 months. So again, as we'll open the poll up and we'll give you 30 seconds to answer that question. There will be an opportunity at the end of the webinar to also provide us with any additional feedback that you'd like to pass on about either your own challenges or about the webinars themselves. Okay, so that's that poll finished. If you'd like any further information or advice on dry cleaning, I have a couple of recommended texts for you. The first is the Guidelines on Hygienic Design, Selection and Use of Cleaning Equipment. This is Guideline 44, available from Camden BRI, and you can find that at the link that I've provided here. There's also a very useful chapter within the Handbook of Hygiene Control in the Food Industry, and I've given you the ISBN number there so you can access that. We're also developing information to go onto our VCAN Knowledge Centre, which already contains a lot of useful information, and you're very welcome to dip into that. Of course, you're very welcome to contact me at any point, and I'm happy to help. And obviously at this point, I'm also happy to answer questions. So if you have any questions now, I'd be very happy to take them. Okay, so I have a question, the first one. What type of products are recommended to remove allergenic proteins in dry environments? That's a really good question, because to properly remove allergens to a level where you're confident that the allergen has been removed, so it's not a food safety hazard, it probably requires wet cleaning, to be honest. The best thing to have is a setup where you can either remove the equipment to a separate area for cleaning, for wet cleaning, and then reassemble when it's dry back in your dry cleaning environment, or to have a completely segregated area, so that if you do have to use water, you can then thoroughly dry that environment before you start production again. Microfiber actually is very good at removing levels of allergens after a thorough clean. So if you do a dry clean first, where you're using vacuuming and brushing, you can then use microfiber to go over those surfaces, and it actually is a very good way of removing allergen residues too. Okay. Are the studies you refer to available for review? They are both available from Camden and from eHedge or Woodhead Publishing, but they are available at a cost. So I'm afraid they're ones that you will have to purchase. If you're a member of Camden, the cleaning guideline will be cheaper for you. I don't know what the current costs are. I think you're probably looking at around £30 to £40 as a member, and maybe £50 if you're not. The hygiene handbook, I really don't know how much that is at the moment, but I'm sure if you go on to Woodhead Publishing, they'll give you a price. No, I just read that one again, and I'm wondering whether the studies, do you mean the studies that I referred to in the presentation are available for review? A lot of the information that I've talked about today does appear in guideline 44, so you can use that guideline to find out more. How can separate environmental bacteria settling to a plate versus actual droplets vomiting? How can separate environmental bacteria settling to a plate versus actual droplets vomiting? Not exactly sure about that question. Possibly if you could drop me a line after the webinar, I can get to the bottom of what you're trying to ask there and get back to you. So can the exhaust from a vacuum cleaner increase the risk of using that particular cleaning tool? Yes, I think is the answer there. That's why I mentioned that it's very important to fit the vacuum cleaners with the appropriate exhaust filters. Obviously, say you're dragging in air and the contaminant that you're trying to control, plus any environmental contamination into the vacuum cleaner. The air that gets drawn in has to be expelled, and if that air doesn't have to go through a filter first, then obviously there are going to be particles and bacteria that can be exhausted with that gas, with that air. So the idea is to have an appropriate filter fitted to the exhaust so that that doesn't happen. What about the use of shop towels that get cleaned regularly? Towels are fine. I mean, say we're already using fabric cloths within food manufacturing for cleaning. The biggest issue that I've had reported with normal fabric is the loss of fibres from things like cotton fabrics, which can say then in themselves cause issues with foreign bodies. Again, you'd probably have to do a risk assessment of your production to determine whether that is an issue with your particular product, or whether something like microfiber that isn't as likely to lose fibres would be a better option. Question on microfiber cloths, we're getting quite a lot of those, which is interesting. What is the recommended method for cleaning them? The recommended method is to launder them with a validated laundry process. So if you establish a cleaning protocol where you're using microfiber, you'll want to work closely with the provider of the washing equipment, or maybe a third-party laundry that does your laundry for you, to ensure that the program that they're using is adequate to remove whatever the hazard is. So whether that be allergens or microbial contamination or even foreign bodies. So washing, wet washing, using washing machines, but using a validated process that you have developed in conjunction with either your own laundry system or your laundry provider. Okay, the next one, what is the best way to keep brushes free from contamination between jobs or shifts? Again, if you're talking about dry cleaning, probably between jobs or shifts is just to knock or brush any of the gross contamination out of them. If you get to the end of one shift and you then need to use them for the second shift and you want to wet clean them, as I said, you might need two sets of products, two sets of brushes, so that you can take the first lot off and put them through a wet cleaning process, but then get them thoroughly dry before they come back into service. And in the meantime, the second shift uses the second set of brushes, which have already been through the process. If you're talking about wet cleaning and you're in a wet cleaning environment, then you can use sanitizer baths. So you can put the products into a bath which contains a sanitizer, which will knock out some of the bacteria between uses. But again, those sanitizer baths, in the same way as the boot washer, need to be managed properly, and the liquid needs to be changed on a frequent basis so that you don't end up with a microbial soup. Okay, I think we've actually reached the end of our time. So I'd just like to ask you one final question on the poll. If I can get my screen to work. And that is, on a scale of 1 to 5, how did this webinar meet your expectations? So if you could rank them from 5 being better than expected, down to 1 which could be improved, that would be much appreciated. And as I mentioned earlier on, there will be an opportunity when you log out of the webinar to add any other comments you have or feedback for us, which would be very much appreciated. So I'd just like to thank you very much for your time today. I hope you enjoyed it. I hope you found it useful, and we look forward to getting your feedback and to you joining us for the next session that we have. Thank you very much.